Yeah, thanks, James, for the introduction. And good afternoon, everybody. Thanks for your time this afternoon. And this is first one of our webinar series for the year 2016. And today we are going to discuss building high throughput in-memory services and solutions using Terracotta. We can actually define throughputs as the rate at which the requests are processed, or the number of requests processed in a given amount of time, let's say in a second. In-memory solutions, services are used to store data in the memory as opposed to store them in file systems for faster retrieval and to achieve higher throughputs. And today we are going to start with one of the characteristics of ESB, which is hosting enterprise services. And then we'll discuss typical challenges in hosting enterprise services in ESB and in-memory solutions that can mitigate these challenges. And we will also go through different flavors of products available from Terracotta and typical usages of Terracotta in the software AG environments. And then we'll follow by a demo of one of the solutions using Terracotta in-memory products. And starting with the ESB, which is Enterprise Service Bus. One of the main functions of the ESB is to host abstract and aggregate services and compose data from different data sources to respond to different consumers, like portals or front-end applications in the enterprise. And then back-end data sources may include like databases, SAP, and other ERP systems, or could be just file servers. And challenges we typically see in different enterprises with these services hosted in ESB are that there will be delay in response to the consumers. Most of the time, same requests with the same input signature take huge amounts of time every time they are requested. In case of aggregate services, every time the request comes in, the process of aggregating from different data sources take larger times. These challenges make the throughputs of the services to be very slow, and when we consider large number of consumers like portals and front-end applications, and the huge traffic depending on the type of the service. Now, with the in-memory solutions address all the challenges I mentioned earlier by mainly making the data available in memory and avoid the costlier I/O operations. We can also avoid repetitive processing of aggregated services by caching those services and build a mechanism to update those caches when the corresponding data changes in the backend. These solutions, these in-memory solutions, make the enterprise services yield high throughputs by making each individual request faster by possibly 1,000 times when compared to the I/O or file system access. I think while choosing an in-memory product, we need to look for few qualities like the data persistence to withstand crashes and restarts. And also, it should have a failover capability where if one of the node in the in-memory solution fails, the other nodes should take over and process the request. And also, we need to be able to secure the data we store in memory. There is one such product, Terracotta from Software AG. The Terracotta has different levels of products for different use cases. First one of which is Ehcache. Ehcache is a standard based open source caching API that enables applications to fetch frequently used data or cache from the memory. and Ehcache is very scalable. And the next level of product is BigMemory Go. This BigMemory Go can be used on a standalone application server, but the BigMemory resides not on the application heap, but outside the application heap, which is not subject to garbage collections. And this BigMemory on a standalone application server can be scaled up to huge amounts of memory. We can add huge amounts of memory to the off-heap memory on the application server. The next one, the next level of product from Terracotta is BigMemory Max. BigMemory Max is for in-memory management in a server array. Basically, we can add as many nodes as we want in an active, passive, or basically active. There could be some nodes which are active. They share the load, and also they have a mirror array. And the data that the memory that we can add to this setup is unlimited. We can add as much memory as we want, and it guarantees the data consistency, and it is fully fault tolerant, and it has advanced monitoring, search, and management capabilities. We have a Terracotta management console that will provide all these functions. And basically the Terracotta in-memory cache, it basically resides off-heap, and we can create a much larger caches than with the local on-heap memory. We can use in order of terabytes of caching, and again, this is not subject to JVM garbage collection, which will improve the performance of accessing the memory. And the Terracotta cache can be shared across multiple webMethods products. In that case, any Java-based application servers or Java-based products. And clients, they access cache via network, and the data is in order of terabytes, not like gigabytes in the traditional use of memory. And particularly Terracotta for integration servers, we typically use Terracotta in all the, it is mandatory now for clustering integration servers. But Terracotta, we can also use Terracotta server arrays, and we can use the cache stored on the Terracotta server arrays by multiple integration servers. They share the cache on the Terracotta server arrays, and integration servers act as clients for these caches, and they store and retrieve the data from server arrays using Ehcache APIs, built-in services available in the integration server. We can create custom or public caches using the Terracotta server on the integration server. With this, I would like to show you the demo of kind of a proof of concept that we developed with one of the in-memory solutions. This will basically just. So before going to the demo, I would like to show you the typical enterprise service which aggregates the data from different data sources and respond to requests from different consumer portal or any other consumers in the enterprise. Usually, typically, there will be two or more data sources. For example, in this case, let's take one database which contains customer data. It will have all the details about the customer, like customer name, number, and discount percentage for that customer. And another database or data source, in this example, we stored pricing data for all the customers, and this database stores the item numbers, item names, quantity, and price per unit for particular quantity of that item. Typically, we get the request from consumer portal. The consumer portal requests invokes the services like aggregate services in ESB and sends the request to aggregate service. And that aggregate service will fetch the data from first data source and gets the data from the second data source and combines them appropriately and sends the response to the consumer requester. With this typical enterprise services, type of enterprise services, we see all the challenges we discussed earlier, hosting the aggregate services in ESB with the low throughputs and slow responses and time taken by aggregation in the ESB, so and so. And to demonstrate the solution, the in-memory solution, we have set up our lab environment. Basically, we have two databases which contain customer data and price data to simulate data sources. And we have an integration server acting as an ESB. And we have set up a Terracotta server array, 2 active nodes and mirrors for each of them on 2 Linux machines with 80 GB each of memory assigned to them. And we use SOAP UI for to simulate the client or the consumer of the enterprise service. Now, the solution one, what we do in this solution, what we do is we actually developed a framework which is pluggable to any aggregate service in ESB. At this moment, only SOAP type of web services. We developed handlers that are pluggable, and when they are plugged into the ESB service, they automatically insert the cache into the Terracotta server array. And for the next request, the request goes to Terracotta server array instead of the data source. For example, in this case, for the first run, whenever the consumer request sends the request for the first time, it will go to the aggregate service, and with the aggregate service will fetch the data from data source 1, gets the data from data source 2, and processes the data from 2 data sources, and inserts the data results into the Terracotta server array as key value pairs, and using the handler, the pluggable handler we develop, and then inserts the cache and returns the results to the requester or the consumer. But when the consumer, any consumer sends the same request with the same input signature, instead of going to the data sources, it will hit the cache on the Terracotta server array, gets the result, key value pair, and sends the results back to the consumer. This will avoid going to the not only to the data sources but also processing of the data. That time taken in ESB is saved, and in this case, accessing memory is a lot faster than accessing the data sources, data on data sources, and this will yield high throughputs. Basically, if each request takes very less time, then the same ESB service or the server can handle more requests for a given amount of time. Let me show you how this solution works. Let me go to our lab environment. So basically, as I have shown in the presentation, there are 2 tables, two databases, one containing pricing data and the other one containing customer data. And we have a service, ESB service, aggregate service in our on our integration server. And before showing the solution 1, I'll show the service without the handler, basically without adding the handler. So I invoke the service, the ESB service from SOAP UI, and we have inserted some wait time, about 5 seconds. So this is the typical scenario in the ESB environment. it takes about 5 seconds. And even if we send the same request without the in-memory solution, it takes again 5 seconds every time the request is sent to the ESB. But with our handler, a pluggable handler added to the service, we'll see much difference in the throughputs. I just plugged in the handler to the service, same service, and now I'm going to invoke the service. This time it will again take 5 seconds. Now this time, apart from getting the data from data sources, it will also insert the cache into the Terracotta. But as I would expect this time it should be instantaneous in a matter of milliseconds. It should give us the results since the cache is already placed in the Terracotta server array. You might, as you have seen, the data is very fast. Within a matter of milliseconds, the data is returned to us. So this is our first solution. It is just this is our first solution. It is just adding the cache into the Terracotta server array. Now, if we look at so second time when the request came, it went to the aggregate service, went to the Terracotta server, and returned the results. Now, if we look at the advantages and disadvantages of this solution, the response, there will be faster response for the request, frequent requests. If the requests are same and again, the subsequent requests will be faster since they hit the cache. And we don't need to aggregate the data in the ESB service over and over again because it is processed and readily available for the subsequent request. And in this case, very less memory is needed. The memory is needed only for the services that are cached and only for the results that are cached. And at this point, this is a framework which is a pluggable. We have pluggable handlers that can work with any type of SOAP web service. But at this moment, they are only limited to SOAP web services. We are working on some common services for other types of web services like RESTful web services or any flow services. And the possible disadvantage for this solution is there is still a possibility of cache going out of sync. There is a possibility that if the service is cached and there is some time to live, and meanwhile, before the cache expires, if the data changes in the data sources, the consumer will see only the stale data, the old data, not the real data. That is a possibility. And there could still be a lot of requests that need to go to data sources. Apart from the requests that are already sent to the ESB services, if there are any new requests with a new input signature, the request they need to still go to data sources and insert the cache. So takeaway from this discussion is the solution can be used for services with very less frequent data changes. If the data changes, we know that for a service, for example, pricing services in some scenarios, if the data changes are very less in a day or particular period of time, then we can utilize this solution and we can just plug in the handler and make the services cacheable, and we can use these services, this solution for such type of services. Now we have another solution for different types of services which have like more frequent data changes, that we can actually update the caches based on the updates from data sources. If there, for example, if there is an update in any of the data sources, we get that particular record or particular set of data which is updated in the data source, and go to another data source and fetch all possible combinations in that second data source for the data in the first data source, get that data as well, and in the customized service, we build a logic to come up with all the possible input combinations for this particular data set that is updated in data source, and invoke the same aggregate service which is cached using the solution 1, and we insert the cache into the update the cache in the Terracotta server array. And for any subsequent requests which have the data cached already because of this update process, then the request will hit the aggregate services in ESB, and it will directly go to the Terracotta server array and hit the cache and get the results and send it back to the consumer. Let me show you how it works in the demo setup. We have the same service, but I'm going to update one of the pricing record using adapter service in integration server. I will update the price of one of the record. I'll change the price per unit from 90 to probably 72. And when I hit this update, this adapter service will update the data in the database, pricing data. And in the integration server, there is a update service which will update all the data. Which will run, and it will fetch all the customer data corresponding to that pricing data that is updated, and it will start updating the cache. This is the Terracotta management console. As you can see, the cache is updated. There are a lot of key value pairs because of the update from the pricing table. So the pricing table is updated with one row. The update service got the data that is updated in pricing table, and it went to customer data source, got all the possible entries in the customer data, and it combined the data from customer data source and pricing data source, and invoked the ESB service, which is cached, and that service is caching all these entries in the Terracotta server array. And this is Terracotta management console. We have different options like monitoring, administration, and we can even see the cache. The cache is searchable, similar to SQL command, command, and then we can actually clear the caches from the management console. Once that is updated, let me see if that is finished. Yeah, once this is finished, the record I entered is for the item number 789 and the quantity 60. So, for example, if I go to SOAP UI and select any of the customer with the same pricing input for the 789-60 combination, if I choose any customer like C, customer number C, the results are instantaneous. So all the results are cached for that particular update and the pricing. So as you can see, we are getting all the results from the Terracotta server array instead of going back to the data sources. Because if it had gone to the data sources, it would have taken 5 seconds. But in this case, in this case, as you can see, if I take any other pricing combination, the request will still go to the Terracotta server array. Data sources, because that is not cached yet. Now let us evaluate the second solution. So if you see the advantage of the solution 2, the faster response and high throughputs for larger set of requests as compared to the solution 1, because it has all the combinations that are updated, combinations for the updated data set from the data source 1. And with this solution, any update, update in the data, any data source will be taken care of. So all the updated data from data source is available on the cache, so that the cache never goes out of sync with the real data. And still, the memory that is used is still less. It is as big as the updates that are coming from the data sources. The one possible disadvantage with this solution is there could still be some requests that need to go to data sources. For example, there is a new input which is not present in the cache because of the updates from the data sources. That has to still go to the data sources and fetch the data. Takeaway from this is basically the solution can be used for services with occasional data changes. If there are few services that the data can be like the data is updated occasionally, not real time or occasional data updates, then we can employ this solution and make use of the framework in solution 1 and the updates in the second solution. Now, the third solution is basically we maintain all possible combinations, all possible input combinations in the Terracotta server array. Basically, all possible input combinations and their results in the Terracotta server array. In this case, what we do is we get instead of updates, we take all the possible combinations from both the data sources. In this case, customer data, all possible combinations, and pricing data, all possible combinations. Get both the data and data sets, and we prepare all input combinations for the aggregate service, and invoke the same aggregate service which has the framework plugged in, so that it will insert the cache for all the possible combinations into the Terracotta server array. And in this case, any combination of input from any of the consumers, they go the request sent to aggregate service. Aggregate service will definitely go to the cache in the Terracotta server array, and it will respond to the request within sub-seconds and send it to the consumers. Basically advantage of this solution is faster response for high throughputs for all set of requests. Any type of request will be handled by Terracotta server array cache, and none of the requests will go to the data source. And in this case, cache will never go out of sync with the real data when used with the combination of second solution, which is update. Meaning we load all the data, all the caches into the Terracotta server array, and then use the second solution to subscribe to the updates from the data sources and update the data as and when the data is updated in the data sources. And in this case, none of the requests will need to go to data sources, or it doesn't. They don't need to aggregate again and again. I would not say disadvantage, but the limitation of this solution, or the final solution, third solution, is it needs a lot of memory, depending on the size and combinations of data. If the combinations of the data is huge, we need additional memory. But as we know, Terracotta, we can add as much memory we want to the Terracotta server array. It's only memory expensive, but and also this solution, the third solution, we need to implement during maybe occasionally, like once in a year or once in 3 months, depending on the type of the service. The takeaway from this solution is it is ideal for any type of enterprise service with limited, not very huge or complex in nature. With this, actually, I would like our Vice President Ram to take over and talk about a few other options.
Thanks, Varun. Thanks for your presentation. And I think it provides a lot of great insight. I just wanted to also let the audience know that they can use the questions tab on your GoToWebinar panel, and you can probably type in all your questions, and Sariu will address those questions one by one. Before I leave you for today, I know going through this presentation and webinar from Varun, you would see that the in-memory capabilities from Terracotta that is presented today in these use cases actually concentrates a lot more on ESB leveraging the in-memory capabilities. That is your IS, your integration server, and other components. That is a proven methodology that we have developed, and it's a proven solution that we can very readily employ and enhance the existing SOA infrastructure. But I also want to let the audience know that this Terracotta caching and memory-based solutions need not be applied or be considered only for the ESP and IS integration server, but also can be applied for pretty much any JVM. Your Apache servers, your Maven, you can use any of your JDK that are compliant to apply the same logic such way that these application servers can utilize memory-based caching. Now you can ask what kind of caching would an application do. There are many ways, including web servers which need to have extensive page rendering. Those can be part of your memory-based solutions as well. But also it can be used for pretty much any JVM-based application. It's just probably sitting on Apache, Tomcat, WebSphere. Any of these JDK-based engines can connect into this Terracotta server and leverage the caching mechanism by simple configuration. I think what Varun depicted in his presentation of 3 different levels of being able to utilize the cache effectively to increase the performance of the ESP servers. The same logic can be applied for any other application servers as well, and essentially there is a use case where you can even build true applications, whether it's e-commerce, mobile applications, or high-intensive applications that can leverage application data and application database itself completely in memory. That is, you don't really need to have a separate file IO based database at all, especially when you use BigMemory Max in what we call Terracotta array server configuration, which will provide what we call redundancy in the data while it is in the memory as well, which can be taken into consideration for outages as well. So I just wanted to leave that thought with you today, that this Terracotta technology is very exciting, and it need not be only used in conjunction with your existing ESP, which I suppose most of you who have upgraded to 9.5 plus, you should be already on Terracotta. So the infrastructure and the server components are already existing for you. It is just up to you to leverage that capability and improve upon performance of your existing SOA infrastructure. With this, thank you very much for your time. Please, address any questions that you would like to ask our panelists, and we would be very glad to help you.
Thanks from James here. Sir, you there?
Yeah, I'm here. Okay.
Yeah.
Thanks, Varun. Thanks, Ram, for wonderful presentation and the demo on the Terracotta. I hope our audience have received good feedback and good data to implement this. So we'll take the question one by one. The Varun, first question is how clustering works in Terracotta. Can we use Terracotta for clustering of other software apart from SAG product?
So basically, I understand the question is if the Terracotta can be used to cluster any other products apart from software equivalents.
That's correct.
To understand correct, for clustering we need to have distributed caches maintained in any of the other areas where the clustered products or clustered nodes are not present. Basically, I think yeah, we can actually use Terracotta for clustering other JVM-based applications.
Okay, just want to add another point is like that within the how clustering works in Terracotta, I think it uses Terracotta server array file, which needs to be defined on the other server, and same need to be placed on each and every node to be clustered, which is mainly used by integration server as well. Thanks, Varun. Moving to next question, how the integrity of data in cache is maintained? What if pricing change after the data was brought to memory?
Yeah, so yeah, that is what the solution 2 mainly addresses. Basically, I understand the question is, what if the change there is a change in the pricing data after the cache is inserted into the Terracotta memory? The solution 2 particularly addresses this issue. Whenever there is a change in if the cache is already set in the Terracotta server, and if there is an update to the pricing data, we get the updates from the data source. We find all the combinations in the customer table, and we particularly look for the particular cache for that particular combination, and we update the cache so that there will not be any data going out of sync.
Okay, thanks.
So I think to just add to that what Varun had said, we are updating the cached object if the backend has been changed by just invoking the service, the reusable service again with the new data. Of course, we are doing that by detecting the changes through triggers and triggers mechanism. But at the same time, you can actually use BigMemory API to actually manage the cache itself. So instead of, say, you are using Terracotta in a context of applications, instead of our ESB service, which is caching, then you have the ability to control the cache and manage the cache and even change the cache by employing BigMemory API. And BigMemory API also has what we call cross-language compatibility. So that means if you have a .NET application that needs to leverage the cache, we can configure it that way as well. Terracotta has what it calls CL adapters, which will convert the .NET object into a Java object before it gets persisted into Terracotta. On the reverse, when a .NET object or .NET application requests or gets that cache, it will go through the same CL. In that sense, you can actually create cache objects and in-memory solutions that can traverse cross languages. That means you can have an application, a .NET application, persist some data into the cache, while a Java application reads from the same cache. So that is also possible. And I think the previous question was about clustering. You have to understand any application or a server, whether it's ESB, IS, or an Apache-based application. Application want to persist data that is functional to its operation, or application needs to persist data as an application to behave in a cluster. So when two application servers behave in a cluster, they are sharing certain contextual data. That is also can be put into Terracotta. That's what IS servers do. The IS servers, when they actually are clustered together, they are aware of each other. They actually share contextual data in that Ehcache. But apart from that, when a certain IS server actually caches a service, which is a functional service, it has its own cache area within the Terracotta. So right now, your IS will have, if you have one service cache, it will have its own cache within the Terracotta. The IS servers to behave in cluster itself will have the separate cache itself. So if you want an Apache farm of Apache servers to be clustered, we have to figure out what is the cluster context that the servers are currently caching. Maybe they are using IO-based caching or maybe other mechanisms. We can definitely leverage that cache to be put into Terracotta so that these newer servers can also leverage in-memory caching. Go ahead, Saryu.
Okay. Yeah, thanks, Ram. Next question is like, do you use a write-through cache architecture? Like if there are a customer read and write services exposed over ESB, then do you update the cache before updating the database, or you invalidate the cache whenever the data in DB changes?
Actually, could you repeat that question again? Sorry.
Yeah, it says like, do you use a write-through cache architecture if there are customer read and write services exposed over ESB? Then do you update the cache before updating the database, or you invalidate the cache whenever the data in DB changes?
Yeah, with this solution, we actually update the data whenever there is a data change in the data sources.
Okay, thanks. We'll definitely will try to get back to you with more detail on the architecture part on this question. The next question is, can in-memory search capability support complex searches? Example, if I have all the customer demographics data in US, like 300 plus million records, and want to know first 50 who lives in zip code XYZ 12345 and the last name start with S, so can we do it to search in database?
Yes, I think it is possible. We have a search API, Ehcache API, but the cache is stored in Terracotta in a key value pair, basically, but we can actually write these queries similar to SQL queries, and we will be able to get that information using this search APIs.
Thanks, Varun. We'll take one more question and then we'll try to end our webinar.
I would cache write and aspects. Definitely, right now in what Varun had shown, we are leveraging the out-of-box IS's ability to cache a service and its signature and using that. But if you are using BigMemory API and managing the cache, either writing the cache or reading the cache, there are multiple mechanisms of cache usage patterns. You can read through, write behind, and also BigMemory SQL is a language that allows you to apply different query against that caches, and including date-based and enum-based queries as well. You can actually do locking of that caches while your application is utilizing the cache. So you can do explicit locking and then also employ transactional support upon these caches as well. Definitely with that, yes, BigMemory API has a lot of capabilities that you can leverage in articulating a particular solution.
Okay, thanks, Ram. The last question is like, do we need to have a separate license for in-memory solution than what we get along with the IS clustering Terracotta?
I believe, yes.
I think, let me answer that now. Definitely, yes. I think Terracotta as a base license for your existing IS web methods environment actually comes in with a bare minimum of memory that you can utilize for caching. But out of box, the ISs utilize Terracotta server for their cluster behavior. that's the basic that you would get. But beyond that, you can buy Terracotta active cluster as the BigMemory Go, and then also BigMemory Max, which is a Terracotta array server cluster, which can scale and also be redundantly available in a robust architecture. So I would always suggest you to reach out to your software AG account representative to get further and the latest details on packaging of these applications and servers.
Thanks, Ram. Thanks, Varun. Thank you so much for all your support. If you have any further question, please do write to us the webinar email ID, and we'll get back to you with all the details, whatever we have. Thank you so much, James. To you.
Thanks, Saryu. So you are saying something?
Yeah, actually, yeah, I would like to say thank you to everybody for their time. And also, we can actually customize these solutions for your environment, or customize this presentation also for your environment. If you are interested, please reach out to us, and we can build. We can help identify use cases and build a proof of concepts for your particular scenarios. And thank you, everybody, again.
Thanks, Varun. We'll share the link where you can find the recording of this session, and even the presentation will be shared to whoever you need. You can write back to us. We can share the presentation too. And thank you so much. Look forward to see you on our upcoming webinars. We'll share the invite very soon. Thank you so much. Have the rest of the day good, and we'll see you on the next webinar.